I want to talk about something which is even more different than everything else we've been hearing today than most of the presentations here, although a lot of interesting stuff here. I go back to when I was actually coming to the MEF a lot for the technical committee. And I was talking then mostly about performance management, the PM stuff, because I was working in the ITU on Y1731 on the PM stuff. And recently, I've gone back to that. After a long time, I've gone back to thinking about PM a lot, and I want to tell you why. Now, the reason I've gone back to that is because nowadays, what we mean by a service is completely different than what we meant by it when I was working on PM many years ago. We used to talk about a pure communications or connectivity service. I've heard the words used. Basically, bring some bits from here to there. Maybe you have some constraints, like you need this bandwidth, this delay. But when we say a service nowadays, we're talking about what I call a rich communication service, which means not only do we have to transport those bits from one place to another, we have to do non-trivial processing on those bits along the way. And that non-trivial processing could be something simple like a NAT, or something a little more complicated like a firewall, but it could be a TCP proxy, it could be doing some compression for WAN acceleration, it could be transrating, it could be changing the size of a video to fit on the phone that it knows that you're using. It can be really complicated things. It, of course, could be security. So when we talk about communication service nowadays, we're talking about something much more complex. The richness of the communication service really fundamentally changes what we're talking about when we say a service. Now, why did we look into quality of service parameters, and why did we define these SLAs that contain them, and why did we measure them? Well, the reason is really what we would like to be able to monitor and to guarantee to our customer is quality of experience. Now, quality of experience is very subjective, and it's always end-to-end. And it's really, really hard to measure in general. Certainly, back 100 years ago, when people started looking into QoS, it was completely impossible to directly measure QoE. So what we found over time was there's a whole bunch of these parameters. We call them QoS. Now, that's a fake kind of name. Really, what do we mean by QoS KPIs? We mean a list of parameters which are easy to measure and that we believe that they correlate somehow with the quality of experience, which is what we really want to guarantee. Now, some of the work I did over many years, and a lot of people in academia have been doing, is to prove that that is correct. In other words, that the QoE is a function of the application and certain QoS parameters like delay and bandwidth and packet loss and things of that sort. And that worked pretty well. We actually were able to prove that, and after the fact, justify the use of these QoS parameters instead of QoE, because there was this correlation, a function I could actually build. We could actually figure these things out between the QoS and the QoE, which is what we're interested in. And that's why we were justified to make an SLA that said QoS parameters and not QoE. But we only proved that for the old connectivity services. We never went back and proved that for these new rich services that we are now looking at with these non-trivial computation going on. And so what I was doing for about a couple of months last year was looking into this carefully, and I found something very interesting. I found out that you can actually prove that it cannot ever work in general. Not only did I find a new formula that proved that QoE is a function of QoS for a given application, I found that there's no way of doing that, and I can prove it very generally. Now, I'm not going to go into all of the proof here, but I'm going to show you a few of the items to give you the idea of why this proof works. And I hope this gets you excited. And I hope they don't start throwing rotten eggs and tomatoes at me, because I'm basically saying that almost everything we've done in the MEF, on carrier Ethernet, how to measure and bandwidth profile and delay, all that is useless today. It's absolutely, it doesn't tell me anything at all. But let me prove it first, okay? I'll do a few little proofs. Now, how does the proof work? The proof is based on, I'm a physicist originally. My PhD is in theoretical physics. And we have this tool called a Gedanken experiment, a thought experiment. I don't have to do a real experiment. I just say, let's try doing something. So what I'm going to do with these Gedanken experiments is to pick a KPI that I think correlates with QoE, and then I'm going to find for every KPI like that a network function where not only doesn't it correlate, it can anti-correlate. You know, things like, think of packet loss gets higher and the quality of experience improves. And if I can do that for every single KPI, I can show you pretty much that it's useless to continue looking at QoS KPIs. So let me show you a few of them. Let's start with packet loss. That's the one everyone thinks about. You know, if you have high packet loss, your service stinks, right? Well, that's true for a connectivity service. But let's think of a first case, an IPS or a firewall. Basically, what does the IPS do? It purposely throws out packets which are bad, right? So had the IPS not been there, you wouldn't have packet loss, but your quality of experience would have been your computer or mobile phone gets infected and stops working. Because of the packet loss, I saved you from that, and therefore the quality of experience is better, right? Higher packet loss, better quality of experience. But it's worse than that. Let's look at this simple thing. This is a TCP proxy. A TCP proxy, for those who don't know, is a function I want to put someplace really close to the middle from the point of view of delay of a service. And the TCP proxy reassembles. It reassembles the byte stream that went into the TCP and disassembles it in a different way. It resegments. So you can have, in a TCP proxy, 3 packets going in and 4 or 5 packets going out, or 2 or 3 packets going out, depending on the TCP parameters and how it reassembles. So notice that if you measure packet loss over the end-to-end path, if 3 went in and 4 came out, you actually have negative packet loss, whatever that means. And if 3 went in and 2 came out, then you have high packet loss. But what is the TCP proxy doing? It's reducing your delay. It's improving your quality of experience. So if you have packet loss because of the TCP proxy, it's because the quality of experience has been improved. If you take it out, there's no packet loss, but the quality of experience is worse. So I know you're looking at me and saying, OK, that's a funny case because we're counting packets instead of bytes, right? Had I counted bytes, it'd all be OK. So why don't we look at traffic volume instead of packets, number of packets? Well, it turns out that doesn't work either, because think of one optimization that uses compression or transrating. Once again, the idea is I'm compressing in order to improve. I'm going over a bottleneck. So there's less bytes. If you count the bytes, there are fewer bytes, but improve the quality of experience. That's why I did it. So less bytes doesn't work, so you're saying, OK, I can do something. He's from academia. Shannon information, right? The number of real bits. Compression doesn't change that. Well, I can show you that that doesn't work either, because think of a caching server someplace along the way. If I have a caching server like a CDN, then what really happens up to the caching server, I'm just sending a hash, which doesn't have pretty much any information at all. And after, from that point on, I'm sending information. So I can actually show you that this tiny little bit of information is enough to send it. So even though you don't see the information there, you're saying all the information is lost. Actually, it's working better than it did before. OK, maybe that's only, oh yeah, one thing. This is I have in small print. In the small print, for those of you who'll get the slides later, you're probably saying to yourself, well, we know how to fix that in MEF. Synthetic packets, right? If I use synthetic packets like SLM, that'll fix it. It's not going to be fooled around with. Yeah, that will measure packet loss correctly, but just think of it. Those packets don't fate share with the real packets. So although you're measuring something QoS, that doesn't mean anything from the point of view of quality experience at all, right? So you can read that later. Let's go on to another one. It didn't push. There you go. Delay. You probably said maybe this is specific to packet loss or information. Maybe delay really is a good idea, and that continues to be a good quality of service parameter. Well, first of all, if we had the TCP proxy, and 5 packets went in and 2 came out, how do you measure delay on the packet? It doesn't make any sense anymore, right? But there's an even stronger argument, and that is, think of what happens when you use a web browser. And if you think of it, the web browser is the end of the end-to-end service when the real end user is your eyes looking at the web browser. And this web browser is basically like a VNF. It's a function that sits there and does something. And what does it do? It takes the bytes coming in, but it interprets some of them as a function, a software function which it runs, right? Think of the JavaScript that you have embedded in your, and quality of experience for web browsing is defined by how fast the picture, the screen, becomes stable. And you could basically have a JavaScript which is taking a long time because of your computer, and it takes a long time to become stable, even though the delay on the network is really, really short. So you measure delay, it's great, and the customer is complaining, right? But that had nothing to do with the network service. And you can do a couple more things like that. Let me show you the funnest one of them all. This is the great one. Let me show you that loss of connectivity can improve the quality of experience, right? Think of what happens if you had two ways of getting from the server to the endpoint, and one of them goes through a server which is running some kind of virtual function or some function you need, and the link goes down. And because of that, the traffic is rerouted, and now the function has to be run on some other server, and that other server either has more processing power available, or maybe has a better upgrade of the software. And so the quality of experience improved. And then later, the other fiber comes back online, you revert, and the quality of experience goes down, and you get a telephone call, and the guy says, you know, it was working really great for a couple of hours. What did you do? And the poor technician looks and says, a couple of hours ago, we had a down on my link. How could it have worked better, right? And it turns out you can go through every kind of KPI. These were all end-to-ends. I've looked at the hap-by-hap ones. I've looked at a lot of ones. You can do this same kind of Gedanken experiment on all of them. And they all show this ridiculous result that there's no connection between QoS parameters and QoE as the end user subjectively feels it. Now, up to now, I've been talking about rich services in general. You should know that with NFV, this is much, much worse. Why is it worse? Well, if I had a static function in an appliance, at least I know it's there. And maybe I can figure out what happened before, what happens after. But once you have NFV, oh, wait a second. I had an animation. Maybe it ran and I didn't see it. Let's try it again. Is the animation going to come up? There it is. You see, a VNF, the function appears, and maybe it moves. And you don't know where it is, and you don't know what it's doing. And it's hopping around on you. So you can't say, OK, I'll measure here, I'll measure there, because the function wasn't there a second ago. And now it's there, and it's doing something funky. And it's changing my packets, and it's changing my delays. And so NFA makes this thing completely useless, right? OK, so the Rotten Tomatoes are coming? Not yet. Well, let me talk that there are a few things we can do. But this is rocket science. Yeah, we're looking at some of this stuff, but this is really atomic physics. What am I talking about? Number one, the endpoints, OK, I have to push ahead really quickly. The endpoints are estimating the quality of experience on a lot of the applications. If we can somehow monitor that and capture that and bring it back to the service provider, we can do something. Number two, there's something called behavioral quality of experience. If the users start turning off their telephones or resetting their TCP connections, I know, I'm out of time, yeah. Then there's a real problem. Number three, you can use synthetic packets but cause them to fade share. In other words, send, let's say, video which is known, and send it over the path and see what happens. You can try correlating using big data, but this is more complicated AI than we were talking about before. This is AI which is trying to figure out what the thing is doing, and that's my last thing. Machine learning, which figures out what functions you have when. Yeah, I didn't have enough time to do this, and this is really, as I said before, rocket science, and maybe we'll start working on this in MEF, and thanks a lot.